Hey, math friends. Welcome to our week 3 of the Figuring Out Fluency book study. I am so glad that you are here. I see some of you are already commenting in the comments. Say hello in the comments. Let us know where you're watching from. And also let us know what your favorite strategy, your favorite fluency strategy from this week was. It was such a great chapter. I think I say that every single week. That's a really great chapter. But we are so glad that you are here watching, whether you are watching live or watching the replay. If this is your first week jumping in, my name is Brittany Heggie. I am the creator of Mix and Math, and I am joined with Meg. Meg has been a new team member of Mix and Math, creating lots of great, content for the newsletter and blogs and doing all of the things. So, Meg, do you want to introduce yourself?
Yeah. Hi, everyone. I'm Meg. I'm from Buffalo originally, but now we're in Rochester, New York. I had some roots in fifth grade math for a little bit of time. I moved on to sixth grade math, and now I'm the math intervention specialist at my school for kindergarten through sixth grade. So, like, knee deep in all of these strategies.
Yes, and what a cool just position to be in because you get to see how these strategies work and how students are using them in kindergarten all the way through sixth grade.
Yeah,
So,
it is such an interesting role. I love it.
yeah, that's awesome. I know you watched the interview last week, but talking to John about the fact that there's so much insight that comes from working with multiple grade levels and then to work with so many grade levels all in one year is awesome. If you are an interventionist, say hello in the comments because you also likely get to work with a ton of grade levels as well. So, we are going to chat all about chapter 4 this week. We are going to dive into that's right? Is it chapter? Look, I
Yeah,
messed up.
chapter
I
four.
put chapter 5 on the top of my on the top of my thing. I was like, "Wait, did I prepare for the wrong chapter?"
I was gonna
No.
say, I hope it's chapter four.
We would both be very unprepared if this was chapter
Yeah.
5. No. We are going to chat about chapter 4 and we are going to dive into the 7 different strategies, but also we have pulled 6 different questions that y'all asked. Meg and I both, I read every single question that y'all asked, and so many great questions. We tried to pull the questions that were like the most commonly asked or were the themes. And so we're going to save a lot more time for questions this week than we have in previous weeks because we've got lots of thoughts on the questions. So let's go ahead and dive into talking about chapter 4. And like every week, I'm going to kick us off with a quote. So on page 77, it says, for students to have access to strategic competence, they must first learn to use strategies and then learn to choose strategies. And then skipping ahead a little bit, it said, teaching a reasoning strategy is not a procedure to be memorized. And I think that that is such a good quote to kick us off because we've got all of these strategies and students first have to understand how to do them first before they can make decisions about when to use them. And in all of this, we have to be really intentional to make sure that students are not just memorizing it, that we're not proceduralizing it. So that is really going to be kind of like the theme of everything we talk about tonight. So I don't know if that quote resonated with you or not, but I highlighted it, circled it, did all the things.
I have so many stars next to that quote. I think it's so important that our students are getting those chances and the exposure to all of those strategies, right? We're not just showing it to them and then moving on from it, but like constantly integrating it into our classrooms and letting them experience them so that they can choose for themselves what is the most efficient way to solve a problem. And it may not be the same strategy every single time.
Yes, and I think it's important also to just acknowledge that for so many of us, we were not given that choice of multiple strategies in how we learned math. Maybe we're not even aware that there were other choices. And so one of the themes I felt like I got from the comments was just a little bit of overwhelm with whoa, this is a lot to teach. It's a lot to take in. And so I think hopefully throughout this discussion, we will minimize the overwhelm and I don't know, just help us all just recognize that students can do these strategies. We just need to be intentional in how we incorporate them into our instruction. So I'm going to have us skip over the do nots because we are going to talk about the do nots in the Q&A. The do nots brought up a lot of feelings. Let me know in the comments if you had some feelings about some of those do nots, but we are going to address those. But I want to at least spend a little bit of time going over each of the strategies. So let's start with the count on and count back strategy. This is one that I feel like is like pretty common for students. Like a lot of students have got this one or use it in some capacity. I know the thing that I really enjoyed seeing was just the fact that students can count on, but they can be flexible in how they count on or count back, that they can change the amount that they're counting on and counting back by. I don't know if you had any thoughts about this strategy.
This one I love for a lot of reasons because it is utilized so young, but especially in the primary ages, like the kids are so used to counting on. I do think we underutilize counting back. Like
Mhm.
I think that is one of the most underused strategies that we have, and our students just need to get used to counting backwards a bit more and like especially when they're younger and like skipping across those decades. But I loved in this strategy the use of context and the emphasis behind context. And especially with the vertical number line, I saw a few people in their aha moments talk about that. And just switching it to a vertical number line so that it matches the context of the story so that they have more meaning behind that strategy.
Yeah, wrote that too. I was like, "Oh, I was like, make sure you consider this." Like we talk so much about making sure the representation or the model like matches the context, but like to the extent of using a vertical number line versus a horizontal one was just like an aha moment for me. I was like, "Oh, I don't know that I was flexible with number lines in that way." So, I love that, and also I think just the importance of bringing in that context really helps students understand. And actually, I brought this up with a different strategy as well. Um, I'm skipping ahead a little bit. It was with compensation.
Mhm.
But that a lot of times we think that context comes after they've got it. Like once they get the math, once they get the strategy, then we can bring in the context. But the context oftentimes gives them something to visualize. It helps them understand why we can. Like if we're just thinking about the counting back, for example, that would be like me having a basket of apples and I'm going and I'm taking like a pile of 3 and I'm moving them. And then I'm taking like a pile of 10 and I'm moving them. It helps them understand like why this strategy works because they can connect it to an experience that they've either had or some visual for the situation.
Yeah, absolutely. And I mean, especially the vertical number line, like we know how that progresses later on, especially like that sixth grade mind that I always go to, like seeing that with integers and negative numbers and like how is that going to work on a coordinate plane later on?
Hmm.
And just exposing that early to our students so that when they see that context later on in life, they already have that connection with the strategy that they've developed. So
Yeah. Yeah. I love that. So, counting on counting back, I feel like that was one that of all of the strategies, we probably are like the most comfortable with. Students start that pretty early. And then we move on to the make a 10, which is also a favorite. And I think the aha moment for a lot of teachers was that make a 10 is not always just make a 10. It can be make a whole, make 100, make 1,000, make a zero with integers. Like that was one that I hadn't actually thought about. And so this make a 10 strategy has such um like a broad way that we can apply it beyond just like, adding 12 and 9.
right. And I think that that was my big aha moment during this whole book. I was telling you earlier, like I wrote in the margins on next to page 82, this is so smart with the unifix cubes and breaking them apart. And we get stuck in thinking it only has to be a 10, but we're really thinking about a whole when we move on to fractions. And I loved the idea of breaking apart the 7/8 plus 7/8 and showing a new whole. And it looks like they were pretty purposeful and intentional about the colors so that the students could even see that decomposition and how they were creating a whole or a new 10 in this case. But those, we were chatting earlier, I think that we just moved so fast past those cubes. And I think that we give those tens rods to our students that they can't decompose way too early and just like giving our students a chance to explore and how they can break apart these numbers because they're so useful not just in the primary grades but later on when they get to those upper elementary grades too.
Yes. So, okay. So if you are not looking at if you don't have your book with you, actually, hold on. If you do have your book with you, go to page 82. Look at the model that Meg is talking about because I think that I've got lots of thoughts on this. I think this is such a good model. And what is interesting is I have seen unifix cubes used to represent fractions before. And I had like hesitations around it because I was like, I think it's easy for the whole to get lost. Whereas like if you're using something like I don't know, like pattern blocks, or if you're using something like blank fraction tiles. Now, granted, the whole can change there, but there's like a visual that that retains the whole. I
Mhm.
think if we're using our Unifix cubes for fractions, we have to be very clear what the whole is. And they did that. They had like the whole up there so that a student knew, okay, in this situation, this is the whole. But one of the reasons that I love this model used in this way is because it allows us to help students see the connection between, or to see the application of the same strategy used with whole numbers and fractions. Because like the model and the strategy is what connects it, right? So students,
Right.
let's say you've got like 10 Unifix cubes there, and students are doing the whole like make a 10 with really easy numbers. And then we move to
Mhm.
fractions and we say, okay, you have understanding, but you're bringing understanding to the table. We're going to take the same thing and now we're going to apply this to fractions. And students have the same model because they're using the Unifix cubes in the same way. They're using the same strategy. The only thing that's different is we're moving from whole numbers to fractions. And I think that when we talk about some of this overwhelm of like, oh, but there's so many strategies they need to learn, a lot of our students, maybe not all of them, but a good, especially when we're talking about upper elementary, our students are either they do own this strategy,
Mhm.
or maybe they're closer to owning this make a 10 strategy, that if we can connect it to what they already know using similar models and showing them what they know first and then applying it to fractions, it becomes a little less of an intimidating like jump. It becomes a little shorter of a leap for them. It's just applying it in a different way. So I actually really really loved this model on page 82, just like you did.
Yeah, I feel like that's such a great point because as soon as we move to fractions, like I don't know, some of us switch away from those strategies, right? Like we fall back into the old those old tricks and tips and things like that. But these strategies really are meant to be cyclical, like throughout all of their mathematical careers. So like we're constantly revisiting make a 10, but now just with a different set of numbers, right?
Mhm.
And now how can we emphasize what we've already learned with this new understanding and what connections can we make?
Yes, absolutely. And just to like re-emphasize this again, I wrote this like in my highlighter letters here, the importance of representations to make strategies visible. Like it is so important. This is not something that, and I think the book talks about it quite a bit. Like, yes, these are things that we want to have discussions about. We want to do like number talks around these and all of that. But we want to do that from a place like we need to give our students that thing to hold in their hands or to see. Um, and that is what helps them really own and understand these strategies. And so I really just like that this chapter they used so many visuals to show the strategies because it is those representations that really help. I think it does two things. One, it helps them understand it, but it also helps them. I say this quote all the time. If, y'all, if you have been in any type of live stream workshop with me, you could probably like quote this along with me because I say it every single time, but it's from Mathematize It. It's pictures and ideas.
Mhm.
Hold the math in place so we can think more deeply about it. And I think when we have these strategies, there were lots of comments about the fact that this is a lot for students to hold in their brain. That is why we have these representations so that they can see it and we can think about it more deeply and have conversations about it. So there's my little like soapbox moment for the evening.
I think no, that's a great point because I think that they also give the students permission to break it apart and change it if they need to along the way, right?
Hmm.
Because I think a lot of our students are perfectionists and they want to get the answer right because they think that with whatever we put out there, we may put out that we value that answer the most, but that's not truly what we want, right? We want our students to engage in mathematics. We want them to be risk takers and problem
Hmm.
solvers and putting out these different representations and something that they can change and manipulate along the way, like gives them the freedom to do that.
Yep, I completely agree. Yes, I love that. So we are always going to, and I think we may have talked about this maybe 2 weeks ago, but we've got the Make Math Hands On workshop, which is not even just about manipulatives. It is really about all of the representations we use with students. So if you've not come to that free workshop, definitely recommend it. We still have sessions, I think next week we've got 3 sessions of it. So, all right. Third strategy was use partials, right? Is
Mhm.
that the third one? There we go.
Yeah. Partials, addition, subtraction, multiplication, and division.
Yeah.
Yeah.
So we had some conversations about this one beforehand, mostly about multiplication and division. Addition and subtraction. Did you have any like strong thoughts on addition or subtraction? It's interesting because the things that stand out for some people are going to be different than others because there are some of these strategies that I'm like, oh yeah, we've done this in number talks, and others that I was like, oh, I had not thought about it. So nothing in addition and subtraction felt like it like super stood out to me. But it may have for you and for others in the comments.
I think that the one thing that's really sticking out to me throughout all of these strategies is the emphasis on understanding the properties within each of the operations as well, right? Like our students really need to understand that we can change the addends, right? But that's not necessarily the case in subtraction. And understanding that when we're going through and manipulating these numbers or decomposing them or changing them into something friendlier for us to work with, they have to have an understanding and a deep understanding of those properties as well. Um, but I found it interesting looking at the addition one where they may have broken apart a first add end versus a second add end, and it's all about like what works best for the student and where they see this strategy helping them efficiently solve, right? But that seems to be a theme, like very underlying theme throughout a lot of these strategies is those properties as well.
Yes, yes, absolutely. Well, and I think something that you said, just a second ago about how it's going to be different for like each student, how they break it apart. And so much of, and I think this goes back to, and I may have said this in the first week, but I think it's maybe worth emphasizing that the strategy that's going to be the most efficient to a student or how they use the strategy is going to be different from student to student depending on like how comfortable they are with the strategy, the level of like number sense they have, or just like their comfortability. Like I think there was one example in here. It was with partials and maybe it was subtraction. Um, but I can't remember exactly where it was, but they like went into negative numbers. I was like, my brain would have never thought to do that just because I don't work with negative numbers often. Now, if I were to practice that strategy, maybe I would think in that way, but that's not going to be initially um, an, a way of using the strategy that feels super comfortable to me. And so it's probably not going to be the most efficient for me until I've had enough practice with it. So just recognizing that how students use these strategies may look different from student to student.
Oh, yeah, I'm seeing it now on there's a chart on page 85 using that integer language and then
Mm-hmm.
subtracting the tens and the negative tens. Yeah, no,
Yes.
that's a great point. It's and I think that that is a big piece of this too is allowing students to have those discussions about why they chose that strategy over something else. And I think we talked about it a little bit earlier where it may have worked for one problem, but it's not always going to be the best solution for another problem, right? And
Yep.
it all depends on the set of numbers that are presented.
Yep. Absolutely. So, and I saw someone in the comments, they were like, I was not a fan of the partial difference. And they do say at the bottom of 85, they were like, we do not consider partial difference a must know strategy for multi digit subtraction, but rather a might know. So, but when we get into partials with multiplication and division, this is where I had lots of notes. So we actually had a conversation before this because the difference between like use partials with multiplication and the break apart strategy, I had wrote down notes of like what I thought it was, but I didn't feel like it was super clear the difference between the two and where I think we've landed. And I'd be interested to hear your thoughts in the comments. Where I think we've landed is that the use partials is like partial products specifically by breaking it apart by place value, right? Is that kind of where we landed?
That's where that's where my gut is. I would really be interested to see what everyone says in the comments. We had a long chat about it, but that is where partial products I have always associated with place value.
Yeah, and
So,
so and I think I've always used a very, like, flexible approach to partial products
mhm.
in that, like, sometimes it's place value, sometimes, like, if you've got 30, you might break it into, like, 15 and 15 if that's easier for you, or, like or 20 and 10, and so I think in that, really, where we've landed, I think, with the break apart to multiply is that partial products by place value is one example or like one way to use break apart to multiply, and that break apart to multiply has like other like uses or ways of using this strategy. I think I'd be interested. Okay, everybody in the comments is like, yes, I agree, I
Yep.
agree, I
Yeah.
agree.
All right, I'm
So
seeing a lot of exclamation points at least, so we're good
yes,
there.
but okay, let's stick with use partials. I jumped ahead a little bit, but
Okay.
partial products, this is one that if you teach Common Core standards or a variation of Common Core, using partial products and breaking it apart by place value is one that many of us are
Mhm.
used to. But I will say one of the things that I am like very passionate about is that I think that it's so easy to proceduralize this and to be like, okay, so we're doing on page 86, it's 321 times, what is it? Is it times 26? Is that,
26, yeah.
yeah, 321 times 26. And we'll say, okay, now to use the area model, you're going to break it apart into the 3 for 300, the 2 for 20, the 1 for 1, and then doing it that way. And then you draw a box, and however many, place
Yeah.
values are, that's how many lines you draw, and then finding that. And I think that, and maybe this is why I've gravitated towards the break apart to multiply as the way that I teach partial products, is because we really lose that understanding of like, why can we why can we decompose 321 into 320 and 1 and multiply in that way? And so while I love this strategy, I do think this is one, I mean, all of them, but especially this one, that we really have to make sure it's built on understanding and students have experience with manipulatives and grid paper. If you came to the workshop, I know somebody said they were here, you saw like the progression of how we build that understanding to get to a place where they understand why the open area model works. Um, so,
I think that's a great point because I think that also when you break it apart by the place value, it doesn't always necessarily lend itself to the friendliest of numbers or the friendliest of multiplication problems, which I think is also why I tend to lean towards the break apart um, strategy instead, because then you have those basic facts that
mhm.
students can manipulate to get to instead. Whereas this one, if you just do it by place value, sometimes you end up with that like dreaded 6 times 8, and they have to go back to a different strategy and break it apart anyways.
Yeah,
So I don't know. I would agree with that. It does fall into a trap every once in a while where it becomes very procedural. So it's rooting them back into that understanding of why this works.
exactly.
Yeah.
Yes. And I think we've got several people who agree with you in the comments. Okay, division. Lots of people commented on this. I had notes about this. It's funny because, goodness, a few weeks ago, I recorded a video on fractions as division, and we talked about the importance of like students experiencing or understanding that fractions are a representation of division, that the fraction bar means division, like all of that. But I had
Yeah.
not even considered, like, this was such a light bulb moment for me. I had not considered really leaning into that and using the fraction bar for division in this way. Like, I just loved how they represented, I'm on page 87. I
Mhm.
loved how they represented division with the fraction bar. I thought it was brilliant.
I have never I have never done it that way either, and I thought it was such a great segue into, well, because at this point, most students are just now getting exposed to fractions when they're also seeing this division standard, and it was such an awesome way to represent work.
Yeah. And I'm curious. Um, if this representation of division with the fraction bar is something that solely belongs in 5th grade
Mhm.
slash if it solely belongs after students understand why fractions can be division or are a representation of division. Um, because if they don't have, and I'm not saying that's right or wrong, this is just something that I'm curious about and thinking
Mhm.
about. I don't have an answer for it. But in order for students to represent division in this way, they have to already know that. And so if we haven't done the work to build students' understanding of why fractions can be division, then we just have to tell them like, hey, the fraction bar means division. So
Yeah.
I don't know. I don't know if anybody has, if you have thoughts on that. I don't know if anybody in the comments have thoughts on that. Like, do we wait to introduce the fraction bar until after they've experienced the learning from that standard?
Yeah, because it could be interesting because the dividend and the divisor certainly represent something in context too. which then could be an interesting conversation to go into what does the numerator and the denominator represent, and like how do you see the relationship between the two of them.
Mhm.
So I don't, now my brain's like, would that be a fun way to kind of introduce fractions then?
Yeah,
I don't know.
I don't know. I don't
Like,
know. This might be something for
yeah,
us to think about, have lots of
yeah.
I mean, and also, if you're watching and you have strong feelings on this, please let us know in the comments because, just as much like while we are facilitating this book study, like we are still learners and there are lots of things that come up that I'm like, I don't know how I feel about this, or like maybe I need to really like reflect on my practice in this way. So that's one that I think this just came up because we had just recorded this video about fractions as division. And we talked about the importance of not just telling students like 2 divided by 3 is 2/3, and 2/3 is the same as 2 divided by 3. How does that compare with this? I don't know. Anyways, okay, let's talk about what was the next one?
I had one other thing I loved for the partial quotients as
Yeah.
well. It was on page 88, and it was they were breaking apart a certain number. And I loved the quote that said, "A student needs the opportunity to observe how the strategy is going. Notice that this is a problem." They were talking about how they couldn't subtract 500 anymore. Um, and then add another product to this list of useful products. And I think that really speaks to giving our students permission to, well, or and us permission to not step in when a student is trying out one of these problems, right? And like give them the chance to explore it and see what is the most efficient way to solve here and have them grapple with the work a little bit. But I thought that that was such an important point to like assess for the reasonableness or just their strategy in general, and like do they need to move on to another approach that might
Mhm.
be a little bit more effective.
Yeah, is that going back to what was it from you just wrote a newsletter section on this. Was it the choose change check?
Yeah. Yes,
Yes.
yes.
And
And
that was that
one
that
of my
change piece?
coworkers was so excited about it. Yes, and she was saying that halfway through, like, we're so used to picking one strategy and then seeing it through, and then we look for an answer, and then we ask, "Did my answer make sense?" at the very end, which is a very, like, it yields a yes or a no, and we were
Mhm.
talking earlier, like, most of our students will say yes because they wanna be right, like, of course it makes sense, so
Right.
carry on from there, like, I wanna get my problem right. But it's having this whole conversation, that metacognitive conversation throughout the problem solving process, where they're asking themselves, what type of question or what type of answer am I looking for here? What strategy is going to help me here? Do I need to adapt and change my strategy as I go? Maybe I started solving and it's not working. Do I have to switch and take another one now? And kind of going through that problem solving process instead of saying just that one question at the very end, did I get the right answer?
Yeah.
So this I thought that this was a great example of that,
Mhm.
just having a student reflect on their work as they go on and then giving us the permission to let that happen because we so badly want to see our students achieve and get the answers right, of course, but we also want them to be problem solvers. So sometimes that means that we need to take a step back and let them go through that process as well.
Yep, absolutely. The importance of and I think this is how this came up maybe when we were talking about it beforehand, but just the importance of like students having the opportunity to do it inefficiently and to get it wrong. Like there's learning in that as well. And so and something that I had to and actually what's interesting is I have to be mindful of this even like in just parenting my son, and it was the same thing like being a teacher as well, is like I'll see them start to do something that's in it. Actually, you know what? I was working with a 5th grade student about this with this like a few months ago, and like I saw her start to it was actually with partial quotients. I saw her start to divide and it was very inefficient and I was like, "Okay, but do you think," and like that's a moment where I can just like hold my tongue,
Yeah.
just wait for a moment, let her get to that point because or else like she's going to be dependent on me always being there being like, "Okay, but could you find a more efficient way? Like, let's think about this." And so I think just even being intentional, I do it with my kids in parenting where I'm like, "Okay, but could you actually do this instead?" And it's like they may need to they may need to experience the pain of having to subtract 12 a million times down the page so that we can reflect on what might we do different next time. So,
Yes. Totally agree.
okay, let's see. So, next we have break apart to multiply. And our conclusion is that this is the more like colorful version of partial products. There are a lot more different ways that they can, um, decompose the factors. And I think they can break apart, well, they can break apart the factors into add-ins and break
Mhm.
apart into factors. That was kind of like that differentiator. And I think Christy actually pulled, she's in the comments, um, chatting with us. And I think she actually did pull that quote that was on page 89 that said, break apart to multiply includes breaking apart by place value, which is use partials, and other ways to break apart numbers. So
Yeah.
I think we were
So,
right.
yeah.
Maybe.
There was someone else in the comments who, and I'm so glad they pointed this out because I started in my book as well. They said the first 5 strategies are those ways of breaking apart numbers, whereas the last 2 really talk about finding simpler ways to solve a problem and like preserve that equivalence. So thank you to that person as well because I feel like that helped us kind of,
Yes.
yeah.
That is awesome.
Yeah.
Um okay, so I think what stood out to me with this one was actually the example on 90
Hmm.
where I'm so quick to break it apart into like into add-ins versus breaking it apart like 45. I would have done 45 times 6 as like 40 times 6 and 5 times 6.
Yeah.
I wouldn't have jumped to 45 times 2 times 3.
I
And
loved that.
I did too.
I thought that was so cool. And then even it's more so just like breaking apart the second factor, I feel like is something that comes natural to me, but I never would have thought about breaking apart the first factor. I think my brain just doesn't go that way for some reason. So I
Yeah.
love 9 times 5 times 6. And then even thinking about, well, 5 times 6 is a fact that I know, and then multiplying that times 9. Like that was a really interesting way to, I don't know, to approach that problem too.
Yeah, I completely agree. And actually something that I wrote down here is and actually I wonder if I pulled the quote. I don't know where the quote is. So, I apologize, but it's somewhere probably 90 or 91. But one of the things that I wrote down was that the whole point of this strategy is breaking apart the numbers strategically into like products that we know. And so, again, an example of this is going to look different for every student, but like, do we know 45 times 2? Like, I do. So, like, it would make sense for me to break it apart in that way. So it's not just like breaking it apart to break it apart. It's specifically and intentionally thinking about like, how can I create a product that is easy for me to get and that I know so that I can then build onto that. So,
Yeah.
I thought that was important to point out.
I think that encourages a lot of flexibility too with this strategy, which is great because once again, it's like it's tailoring to what the student needs, right? Or what works best for them rather
Mhm.
than just following a rule of break it apart by this or break it apart by a fives fact or something like that. It's what works best for them.
Yeah. Well, and something else that I wrote down, I wrote this in the margins on page 91, is just the importance of for us as teachers to truly own these strategies um, for a couple of reasons. Like, one, I think like we have to own these strategies if we are going to facilitate learning around them. But also on page 91, it says like the set of problems you select matters. Like
Yes.
when you are teaching a specific strategy, you obviously want to choose problems that lend themselves to that strategy. And that just brought me back to the importance of like, we can't know or even, um, we can't know what set of numbers to choose if we don't really own that strategy, like if we don't feel comfortable with it. And so, actually, I'm jumping ahead a little bit because one of our questions that we're going to talk about is like, where do I even start with this? And for some of us, the starting place is just let's get to a point of like really understanding these strategies.
Yeah.
Like if that's the only step you take from this, and actually, I think that naturally, if we start to own these strategies and start to use them more, they will come out in our teaching. But I even think if like that's the first step you take, that's a really important step because I know for me, this the breaking apart on page 90, the breaking apart into two factors like this is not something that I typically gravitate to. And so in my teaching, this was not a strategy that I was highlighting or
Right.
even like bringing up in the classroom. And so the more that I am like focused on building this in myself, that will naturally come out in the classroom.
Yeah. And I think that this was something that I would lean in a bit towards more towards whole numbers, but I fell into the trap like younger me would fall into the trap all the time with multiplying mixed numbers and like you learn and you reflect and you go from here, but now that's such a natural progression to learn how to multiply a mixed number that way and use this break apart strategy. And I
Hmm.
feel like it would have been a lot more accessible to my students 10 years ago if I had thought about it that way. So just it's interesting to see like past practices and then
Hmm.
now looking at all of these and how can we grow from there.
Yeah. And what's actually interesting is, and I say all of that like about like, we need to own these strategies, but I also think the way that I got to a place, because I did use when I was teaching like mixed numbers, we used the area model quite a bit, break apart strategy. But I'm pretty sure the first time that came up was because a student did it. And then I became really curious about like, wait, does that always work? And
Yeah.
so I also just want to like caveat my own comment of like I do think that we need to own these, but also we can learn a lot from students. And if we
Mhm.
are curious about their strategies and explore them and dig into does this always work? Um, I think that's really like helpful as well. But yes, I loved that the whole using break apart strategy for fractions and decimals as well.
Yeah.
Um, okay, anything else about that before we move to have and double and compensation?
No, I think that I no, I also really loved the use of a tense frame with the break apart strategy. I think it's on page 92. I think that anytime you can get a 10 frame in view of the students, like that is something that they have seen since, oh my God, day one
Yeah.
of math, right? I love the use of it. I actually there was I think it was a year ago or something like that. Last summer, I took a mix of math PD on facts, like facts and fluency
Oh,
and things like that.
multiplication fact fluency.
Yes, and in the resource, it's a use of a tens frame, and seeing the groups within the tens frame was such a game changer for my students this year because they had that foundation already, and they were able to build upon their multiplication facts that way. So it's something familiar to them, and like the use of the egg cartons within the tens frames, I thought that was genius. Um, but it just utilizing those old strategies and building upon them.
Yes.
So,
And by the way, that workshop on multiplication fact fluency, that is on the YouTube channel. But where you
yeah.
are watching this right now, it is on there. I'm not sure exactly where it is, but it's like a blue cover. And a lot of the strategies in that very much align to what we're talking about in the book. So, and that's geared more towards like fourth and fifth grade teachers.
Mhm.
So, if you were just bored on summer break, which I'm sure none of you are, feel free to go watch that video. But okay, so have and double, which also I want to be mindful of time because I did say that we're going to save more times for questions today
Oh,
because we've got a lot to chat about. So, have and double, was there anything that really stood out to you or anything that you want to highlight there?
I think it was just again being purposeful about the problems that you're choosing. So on page 94, they were talking about a series of questions, and in each of the problems, problem one, two, and four, they all show a number with a five at the end of it, which is going to make having and doubling something a little bit easier, just because it will make a 10 eventually. And they were very intentional about pointing out that we should allow students to come to that conclusion on their own and asking those open-ended questions of when do you use this strategy versus did this strategy work, right? And like really
Right.
having the students reflect on it and using that word when instead.
Yep, that was the only thing that I wrote down for this was when do you want to use this strategy? I love that reflection and maybe even adding on to that like when do you not want to use this strategy?
Yeah.
Like having and doubling is not going to be a fun thing if we're multiplying like 17 by 7. So, okay, compensation.
Yes.
With compensation, my biggest takeaway from compensation, I think I actually like alluded to this or mentioned to this earlier, was the fact that using visuals, using representations is so important with this strategy.
Mhm.
because when we are using compensation, basically we are like adjusting the number or what we're hold on. We are adding to or like changing the number in
Yeah.
some way, and then
Yeah.
we have to basically undo the change at the end,
Mhm.
and that preserves the value.
Yeah.
And I think the reason that representations are so important is because if we're using like manipulatives, um, that gives students an opportunity to see like we are doing something and then we're undoing it. We're adding these cubes here and then we're taking them away. With the context, for example, even adding context where students can kind of like visualize exactly what we're doing to the numbers and what we're undoing.
Yeah.
Um, that was like the big, like my big takeaway from this section is just the importance of the visuals for this strategy.
I think that a big piece of this section too, because compensation isn't something that comes easily to me. It's just something that I have to work towards when I'm teaching it. And we have used balance beams in the past or scales in the past with cubes on either side just to like show the students how we preserve equivalence on either end, like if we are
Mhm.
manipulating something. So just seeing that visual and bringing in that context is really helpful for kids to see we're still kind of solving the same problem, but we're making this simpler for us to work with, friendly or not
Yes.
there.
Yep. And I think that is it compensation. What is it? It's compensation with subtraction is the one, right? That's the one that's often more challenging for students,
Yeah.
right?
Yes.
Yes. Um,
I loved their idea of posing like true false questions. It's on page 97 for situations for students. Like, would this work? Like, if there's an 82 plus 49, and then are these equations true or false? Um,
mm,
and
I
having
love that.
students analyze those because it's not always going to be the case with some of these addition and subtraction compensations, but it is a great way. They made a great point. Regrouping is really tough for kids, and compensation is a way to avoid regrouping and avoid those computation errors.
Yes. And actually, hearing you say that, I think several of these strategies are somewhat like strategies that we can use to avoid regrouping. I heard Annalise Record, I think is her last name. I should know this. I panic whenever I have to say a name live on a live stream. I immediately panic because I'm like, oh my gosh, am I going to say it wrong? Am I going to mess it up? So it's like, Annalise, if you're watching, I really do apologize. I know your last name. But, anyways, I heard her say, I was in one of her sessions and she was talking about how she was like, very rarely should students who are subtracting mixed numbers ever have to do any sort of regrouping. Like, there are strategies just like we've talked about, a lot of the earlier on ones where we're counting on, counting back, or making a 10. And so, when we get into this conversation of like, why do we need these strategies? And we are going to talk about this, about the whole algorithm thing. It's like many of these strategies are actually like set students up to be more successful than there are just so many more opportunities to make a mistake when we are regrouping or when we are using a standard algorithm versus using like reasoning strategies.
Right.
Um, so very
I don't
interesting.
know. I think about problems like 1,000 minus 999 and like watching my students, like we all have those students who will set that up for standard algorithm and they'll go to regroup above like all of those zeros and they'll make the computation mistake and then realize, oh, it's just one. And then
Hmm.
it's like building that number sense in the end, like, is that always the most efficient strategy? But like if we were able to move part of those pieces of the equation, it would have been a little bit faster in the end. So
Exactly. Yes. Okay. Last one because questions. I don't know that I've given us any more time tonight, but we're going to knock it out. We'll be good.
hopefully we get to some of them along the way. I don't know if
I
we
do
did.
think we have addressed some
Okay.
of them. Time management is not my best trait. Okay, so
Inverse relationship.
yes, inverse relationship. And this one, I think it even specifically says like we rarely use this for addition and multiplication. Usually when we get to subtraction and division, we're think addition um or think multiplication. Was there anything specifically you wanted to highlight here? I don't think outside of the fact that in this same section, it talks about explicit strategy instruction.
Right.
And I literally wrote on my page, it says page 103, the whole page. So not that we need to talk about the entire page, but I do think, and John emphasized this last week about what explicit strategy instruction is. And
Mhm.
so if you are a skimmer and you're just kind of like going through skimming the book, I would say read 102 and 103 like in depth, because I mean, I really truly did it. I highlighted like half the page.
Me too, actually. Yes, you can see my notes as well. But I love for 103, it says using how to use them and then using how to choose them. So giving our students options of understanding these strategies and then figuring out what works best for me from there. And then this is the conversation, and I know we're going to get to it with the questions where the standard algorithm comes up and the
Let's go
procedure.
ahead and jump into it because we are jumping into questions, and that was one of the questions. It says on the bottom of page 103, it says standard algorithms should be treated as the last resort after first considering more efficient options. And I don't remember exactly, let me find the question. You're getting a little sneak peek of the questions that we are going to ask tonight. I wanted to find the exact question because I thought it was interesting. Okay, apparently I didn't pull this question. So let's talk about it anyways. How it was worded. I can't remember what it was, but maybe the question was around like, why is the standard algorithm the last resort?
Or even some of our students, a lot of the aha moments were a lot of our students had already been exposed to the standard algorithm. So now, how do you kind of not necessarily undo, but how do we show them these strategies when they've already learned a procedure and a way of solving? So, kind of working backwards from there.
Yeah.
And I think that speaks to one of our questions about like introducing this so late
Yeah.
to students if they haven't.
So let's stick with okay, students know. And if you are someone who is watching live and you've got that question, feel free to put it in the question. I'll kind of keep an eye on the chat. Or put the question in the comments and I'll keep an eye on the chat. But so let's stick with okay, they've already been introduced to the algorithm. Now, how do we show them the benefit of these strategies? I think one, the algorithm can be, and hold on, let me also say this. There are times when the algorithm is the most efficient. There is an activity, I can't remember, I actually think it's in next week's chapter, where they essentially have students, there are like 3 problems, and you have to decide like algorithm, calculator, or one of the strategies or something like that. And it's basically to communicate to students that there are times that a like mental math strategy or like our fluency strategies are more efficient, and there are times where an algorithm is more efficient. And so I think not, this is not saying that the algorithm is never the right choice. It is saying that it shouldn't be the first choice. Like students should have strategies that they can lean on, like compensation, for example, where we're talking about like
Mhm.
1000 minus 987. Well, we should have a strategy to say, okay, that I would actually use count on for that. Like it's going to be 3 versus having to regroup across zeros a million times.
Right.
And so, yeah, what were you going to say?
I was just or recognizing, like, can we make a 10 in one of these situations, right? Is
Mhm.
that gonna be a lot faster? Back to that 1,000 minus 999 example, right? Like,
Mhm.
making the the conscious choice to look at all of those digits and figuring out what is my best approach here versus then just lining it up for a standard algorithm every single time.
Yeah, and I think so I have a couple of thoughts. Like one, I think that maybe students need to actually see that this isn't
Mhm.
always the most efficient. Like exposing them to 2 different sets of numbers, one where the algorithm is great and another where a reasoning strategy makes more sense. Um, I had another thought, but I lost it. But I think I don't know. And I also just think in our own lives, like like how often or if, even efficient is it for us to use a standard algorithm when we can just like I don't know, use mental math strategies out in the world. So I don't know. I think some of it is just having conversations with students, exposing them to different sets of problems, and even just making them aware of the fact that they don't always have to use an algorithm. For some students, the algorithm is their first choice because it's the only strategy that they have. They
Right.
don't know any other things. And so when we expose them to the other things, they might make a different choice.
Yeah. I think that chart on page 104 is so important because of that, like having students have that metacognitive process about a strategy once they've been exposed to something other than a standard algorithm, then going through the can I do this in my head? Is there something that would make this problem simpler? And then following that chart. I think it's such an awesome resource.
What
Um,
chart are you on, or what
I'm
page?
on page 104 on that
Oh,
next
yeah, yeah,
page,
yeah. Oh,
figure
yes.
412.
Mhm.
So once they've been exposed to something other than that standard algorithm, going through this process in their head, can I make this problem simpler for myself rather than just the procedure that I've learned?
Yes, and so something I wanna add to something in the comments made me think of this, but I think a lot of times we're like, "Oh, but we can't get students to use anything other than the algorithm." Well, then I think we need to change the questions that we ask,
Yeah.
because if we put them in a situation where it's not find the answer, but it's, like, is the algorithm an efficient path for set of problems? Is it for this set of problems? Like, I think sometimes we just need to change what we're asking students to where it is, because kind of what you're saying with this whole like megacognitive process for selecting a strategy, like having these discussions around the number sets, um, it really kind of removes this like, oh, but my students are just doing the algorithm. No, let's have a conversation about other strategies.
Yeah. I love that stop and reflect for that reason. Like integrating the word when into
Hmm.
your practice, right? Like when could you use this? When could you use simpler number and like how to incorporate that into your classroom discussion, like you said, versus just saying find this answer. Because I think that's when we start to fall back into the tricks and that's where the conceptual understanding, then we start to lose that.
Yeah. Okay, I want to look at some of these questions because there
Mhm.
was. All right, we've got like 9 minutes. We've got this.
We can do it.
This question specifically, I'm going to like summarize this. The question was, if a student is adding 675 and 475, they would need to basically, this is the like make a 10 essentially. It's like make 100. But then they would have to do 475 minus 25 in their head. I find that confusing for students who cannot do that on their own, like in their mind. Essentially, what this is saying is this strategy confusing? I think this strategy is too much for students to hold in their head. And this actually goes along with one of the do nots, which was like, do not ask students to show, I forget how they worded it. What was it? Like, do not ask students to show their
Show.
work. Do not require
Yeah.
students to show all their work. And so I think that the this idea about not requiring students to show their work, I think that one, some of these things are not like hard and fast rules. This means that students never need to show their work. I have changed to document your thinking. Sometimes documenting our thinking is helpful for others, but it's also helpful for ourselves. And I think also helping students understand when writing something down might be helpful to them. Like for some students, this problem is not overwhelming for them because they're so fluent with like they're being able to subtract by 25 that they've got this. For other students, this may be really challenging for them to do in their head without
Mhm.
writing something down. And so I think some of this comes from where there's so many conversations that we are having in this book around having conversations with students. And I think even talking to students about like, could writing this down help you? Would it be helpful to do this quickly just to retain that number in your head for you to be able to continue the strategy? So I think that the do not require students to show their work is not a hard and fast rule. It
Yeah.
changes depending on the situation, also changes depending on the goal. Are students working independently and you want to analyze their thinking later on and provide feedback? That might be a situation where students are documenting their thinking, showing their work. Does this problem require a lot of different steps? And I have to show my work sometimes just to keep
Mhm.
track of all of the things I'm doing, especially like when I'm budgeting and things like that. So um, that I kind of hit, two questions with this, but I don't know if you have any additional thoughts.
No, I agree with all of those. I also think that so this one was hard for I think for a couple of us to read just because we always ask for our students to show their work, but I am definitely someone reflecting on past practices. I was someone who would always say like I need to see what you're thinking. But it's hard for some of our students to show what they're thinking if they can't verbalize what they're thinking beforehand, right?
Mm-hmm.
Like they may need to talk it out beforehand and explain to you, I'm thinking I should start here, but I'm actually starting here. And like you learn so much more from a student by sitting and interviewing them, right? Rather than looking at a piece of paper, because there are so many times where I get a paper in front of me and I'm like, I wish I could have heard their thought process
Yes.
behind this, because there's eraser marks and you're trying to go back into
You're
it,
like,
but like,
where did this start?
yeah, and I'm like, I know you had it, but I don't know where we went. I don't know, but I think it's so important to really emphasize that, and I think that that statement, the way I interpreted it was, we're not asking students not to show their work because we want it to be all mental math, but because we want to give them permission to start to assess this reasonableness and talk through these
Mm-hmm.
problems, more so than just worrying about how can I capture this on my paper so I can submit it.
Yep, absolutely. And I think just recognizing too, this said like strategies are often fully or partially done mentally, which is more efficient.
Yeah,
Recognizing that, and we kind of talked about this beforehand, like a student might need to show their work or document their thinking for like, I don't know, 12 minus 7 when they're in kindergarten. But like a sixth grader doesn't need to show that. We probably wouldn't even expect them to show that because it's so just like they've just got it mentally. And
right.
so recognizing that the amount of work, like a student can be doing really rich thinking, and the amount of work that is like needed or expected to document is going to be different depending on kind of like where they're at. So I don't know. I think with all of this, I've read enough professional development books to recognize, and this is a really good example. We just talked about this. So last summer we did Productive Math Struggle. Summer before that we did Building Thinking Classrooms. And in Building Thinking Classrooms, granted, these authors, both fantastic math educators that I really respect. But one of them really promotes randomized groups. Another one, there was a chapter, there was a very specific sentence that said, be very intentional in how you group students. And these were two contradicting things. And so anytime I'm reading a math professional development book, I try to understand that like one sentence is not applicable to everything all of the time. And so going back to this, like, do not show your work, but also what was the other one? Like, do not regularly ask students to solve a problem two or more different ways.
Yeah,
I think the key word here is regularly. Like,
yeah,
there might be times where that is helpful. Um, in the two ways, this is kind of like arguing, are we talking about two strategies here or two models? Like, I think it's really helpful for a student um, to solve a problem in one way with one model or one representation, and ask them to, what would that thinking look like using another representation that actually helps
yeah,
them bridge connections between like their manipulatives and a visual model.
right.
Is this talking about strategies or representations? I'm not sure when they, how they said that. But it's like, I think we can read these things and take the message from it and also understand that there may be specific applications for it. And here I think it was like, we're not regularly asking students to do that. I don't know. Is that how you like took it, interpreted it?
No, 100%. I feel like it's a very much like a time and place situation,
Mm-hmm.
where there are
Yes.
situations where like this is appropriate and there are other situations where we would want to foster more of a conversation from our students. And it's, I mean, we've had so many discussions where like the math block isn't going to look the same every single day. And I think that's the beauty of it, right? We want to continue to like grow with our students and give them opportunities to discuss and like have this discourse so that they can become problem solvers and they can figure out the best way that they want to approach a problem, and giving them those opportunities to do so.
Yes. Okay, we have like 2 minutes, but we may go just a tiny bit over. But I really want to go through. I think it is this question. Okay, I want to go through this question because I actually saw some conversations about this in the comments. And I'm not sure if it's this specific question, but the overall like theme of the questions I felt like this week was just a lot of overwhelm of how do we incorporate all of these strategies in the classroom. We're already like pressed for time and our pacing guide moves so fast and all of that. And so I actually thought it would just be helpful for us to basically like, if Meg and I are just like brainstorming in a classroom together, having a conversation around this, like looking at our standards and just saying, okay, how can we bring these strategies in? So I'm actually just going to pull up. I've got the Common Core app on my phone, and we are going to look at 5th grade standards, and we are just going to kind of go down the list. And my hope is, even if you're a 3rd grade teacher or a 4th grade teacher, my hope is that you can see how this can like I don't want to say like easily. I don't want to like minimize this in any way, but how we can have a plan to where this doesn't add more to your plate. So there's 2 things I want you to do. One, if you have the Common Core app on your phone, or if you have your standards, pull out your standards, and you can come back to this section on the replay. The other thing I want you to do is I want you to actually turn to page 195. So we are not reading chapter 9 in this book study just because we would have had to add a 7th week, and I already think 6 weeks is long for summer break. But 190 or chapter 9 is all about planning. And so there's a really great figure on 195. And so let's look at our 5th grade standards, and we're just going to kind of like go through these and figure out like which of the 7 strategies do we think we can incorporate in here. It may be multiple, and it's probably not going to be all 7. So I'm going to start with, and these are all of these strategies are for operations. These are not like our automaticities or utilities, whatever they call them in later chapters. These are all operations. So we're just going to look at our operation standards. So 5 NBT 5. So fluently multiply multi-digit whole numbers. Like, which are the ones that we are, and I've got to flip back, specifically which strategies do we want to incorporate? Sorry, I'm having to switch to my list of strategies.
No, that's okay. I'm on one post-it to the next. Here we go.
Okay, I switched back to 105. Okay, so for this one, obviously break apart to multiply, which break apart to multiply in my brain also includes the use partials.
Yep.
And half and double.
Half and double, I feel like, for sure.
And the compensation, which interesting. Well, actually, you know what? I was going to say, interestingly enough, I don't think I use compensation as much. But do we use compensation with like multi-digit whole numbers?
I feel like it would be, we could. I just feel like it would be more complex for students, but that's the way like we would be working our way up to that one.
Yes. And so let's say, okay, so let's say we're specifically focused on like break apart to multiply, because I just will forever include use partials in there. Like it is included. So let's say there's only, of this list, there's only 1, 2, 3, 4. If you're the rebellious one like me, 3. There's only 3 strategies here that we can use. I might start by saying, okay, I think break apart to multiply is such a huge one for this. It is not like the only one, but maybe one of the main ones that the standards are focused on, using the area model and all of that. So maybe I'm going to, for like my number talks this week, like we are just going to focus on this strategy. I might start by actually showing them or giving them a problem with a strategy with a multiplication fact that they know, because we use break apart to multiply for like our 12s facts, for example. So maybe we'll do a couple of those. And then maybe we'll go beyond that and maybe be like, okay, well, what would this look like with times 13? And have conversations around like, well, why does this work? How would we model this? And then we start applying this to those grade level numbers, which are the multi-digit whole numbers. That, I don't know. That's just kind of like, if we're just like riffing, that's kind of like one of the ideas I have for incorporating this strategy into a standard I'm already teaching.
I feel like that strategy too would make a standard like that with the multi-digit whole numbers a bit more attainable, because of how large some of the numbers can get and how large some of the place values can get. So using that break apart strategy is going to make it a little friendlier for students. I also think in that, I love that chart because it says there's context that fit. And I always, if you're doing like a number talk one day, I always found it helpful to like continue that same context throughout that number talk throughout the week, so that they continuously make that connection between the strategy too, and whatever you may be counting. And like in our one example, it was eggs, but like maybe now you've got an extra egg or something like that they're adding in for the 13 or 14 or 15 and carrying on from there. But really being purposeful about how we're choosing that context too when we're
yes
in with a strategy.
Yeah, I love that idea of keeping that same context for the entire week. And so maybe that is the focus. Like maybe that is the focus strategy. Like this is a standard that takes a bit of time. Maybe that is the focus strategy for that week. And actually it's something that we probably to some extent are already teaching that strategy. Maybe not for understanding, but it's one that's kind of already being incorporated. So maybe now, if that one's kind of like already ingrained in your teaching, maybe we focus on the idea of like having and doubling and showing students again, maybe it's in our warm up time where we are doing that number talk, or we're bringing in one of the routines from the book where we're saying like, okay, let's look at a new strategy that's called have and double. It talks about the fact that we need to have explicit strategy instruction. And so then students are on the hunt. This week, we are specifically looking for problems like as we are going through our normal work, but maybe we have like a little, I don't know, tally on the board or something. If anybody comes across a problem that would be better for us to have and double. And like that's the extent of it. We're using the warm up to specifically teach the strategy. And then maybe we're intentional in our planning to just be like, leave those little Easter eggs of like, oh, this is a really good have and double problem. Let's see if anybody catches it.
Yes.
And like, I don't know. I think I'm sure that again, we're just riffing. I'm sure that there are much more intentional and thoughtful ways, but I think it can also be this like light to some extent as we're getting started. I don't know. Do you have any other ideas?
I think that's a great idea if you went through one strategy one week and then maybe another week you're doing a number talk with the have and double, and then like towards the end of the week having a conversation about why did this strategy work better than this strategy for these types of problems, and like that's where the efficiency starts to build, right? Now that the students have that explicit instruction and they have these understanding of these strategies, where now they're able to start to choose what works best for them.
Yep. I love that. We are like so over time. So I was going to go through another standard, but I think these are the same conversations you can have whether you're with someone else or, I don't know, by yourself. I hope you're not by yourself. If you are by yourself, then you need to come join the like mix and
Yeah.
math communities or something so we can have these. Yes,
Yeah.
we just launched a brand new community this week, but please come in our circle and have these conversations because I don't want you to have them alone. But I think it's like I mentioned this to Meg beforehand. Like when we have like this is where students are at, and then we are reading about the goal of where we want students to be, and we haven't taken the time to actually think about how we get them between A and B, this gap feels super overwhelming. And sometimes we just need to play it out. We just need to look at a very specific concept and map it out, which is why I actually pointed you to 195. I realized that I did not actually like clearly explain why I wanted you to go to 195. But it was because I really liked this chart of saying like, okay, we've got this standard, we've got this concept. What strategies could go along with it? What visuals could I use? What context, Meg, just like you said, like what contexts fit? And then any other notes. And then when we start to talk about it and we start to actually play it out, it's like, okay, it's not as overwhelming. And sometimes we just have to play out like, how do we get between A and B? So all right. I know we still did not get to y'all need a different host. You need a host who has better time management skills. But thank y'all so much for joining us. Meg, was there anything else that you had to share? I know I just like cut us off.
No, I love this chapter. I think it's just one that I'm going to continuously reference back over and over again. And I think it's just really all about just exposing our students to these strategies and having them take the time to figure out what is the best strategy for me after they have had that explicit instruction, and giving them that flexibility to make that decision with their work. So
Yeah.
it's a great one. It's definitely going to be bookmarked for a while for me.
Oh, for sure. For sure. Thank you so much for joining me. You are the best. This has been so fun. This was Meg's first Mix and Math live stream, and you killed it. So thank you so much for joining me. I did just want to give you a quick heads up about next week. So next week we are going to have a live book chat. It is with Rosalba. She is one of the authors of the companion books. Both Christy and I are actually out of town next week, so I have pre-recorded this interview. So I believe Christy will actually be live in the comments. I will not be tomorrow, next week, but we are still going to stream it live. So it will air right at 7 p.m. Eastern on Thursday. Just know that neither of us will be live. It'll be a recording with the author. But we are so thankful for you. Thank you for joining us for week 3 book chat. And I hope y'all have such a wonderful evening. And I cannot wait to talk math with you again soon. Bye, everyone.